right, y'all. So let's talk about our last bit of information for this concept. This is the part that's going to probably take us a little bit longer to kind of work through. We're going to practice this a lot. No worries. This is going to help you visualize how to actually make ionic bonds. So I almost said iconic. Miss Helms is out of it. Okay. So let's go ahead and talk about electron dot diagrams. So because we only care about valence electrons when we're actually using drawings to show how bonds will form, we will now learn a new and actually simplified diagram from that of the Bohr model that we were using previously. So those of you that were like hating life because of Bohr models, you're going to love life now because this is easy. So these are called electron dot or Lewis dot diagrams. You'll kind of hear me say that name interchangeably. It just depends on what comes out of my mouth, honestly, with this. But this is an example of what they look like. So these are different, obviously different elements that just literally show their valence electrons. So let's go ahead and talk about how to actually draw them. So when drawing, the nucleus is represented by the atomic symbol. So an example would be nitrogen. There's a capital N for its atomic symbol. Then you're going to determine the number of valence electrons from the group number. We've done this before with Bohr models. Then you're going to represent the valence electrons by drawing the number of dots around the chemical symbol. As a note, make sure you fill one side at a time before you pair electrons up, just like I taught you guys to do during Bohr models. This is a good habit. That's why I had you guys start that then. So, for example, nitrogen has this many valence electrons, and we did that in a circle. And then it went ahead and started adding and pairing just like this. So nitrogen has 5 valence electrons, so there are 5 valence electrons on our electron dot diagram. So let's go ahead and practice. Here are 4 different elements for you to work on. I'm going to have you go ahead and pause so you can go ahead and work on this, and then you can check your answers when you're done. I'm going to have you use the drawing function on Google, excuse me, on, not the drawing function, you're going to use the shape function, excuse me, on Google Docs to go ahead and complete this. Okay, so here is what your answers are. So hydrogen looks like this because it only has 1 valence electron. Carbon has 4 valence electrons, so this is what it looks like. Fluorine has 7 valence electrons, so this is what it looks like. And phosphorus has 5 valence electrons, so this is what it looks like. So let's go ahead and start using these electron dot diagrams to show how bonds are formed. So first things first, you're going to draw the electron dot structures of each element, and then you're going to transfer those electrons using an arrow from the metal to the non-metal. Then you're going to add the elements, add elements as needed, and I'll give you an example of this as we practice this next week. And then you're going to continue transferring until all atoms are stable, meaning they have 8 valence electrons. Then you're going to write the chemical formula using subscripts to show how many of each element were needed. So let's go over an example. So what compound will form between sodium and chlorine? So first of all, sodium has 1 valence electron like this. Chlorine has 7, and you place them just like that. Now what you're going to do is you're going to transfer the electron to the from the metal to the non-metal, just like this. And that is the chemical formula that you come up with for sodium and chlorine. That's sodium chloride. Example number 2 is aluminum and chlorine. So this is what aluminum looks like before we place our electron dot or electrons on there. Aluminum has 3 valence electrons. Chlorine again has your 7, just like this. So you're going to transfer the 1 that aluminum needs to give away to chlorine to be positive, or not positive, to be completely for chlorine, and aluminum is good to go. But you still have 2 more of those aluminum electrons, so we need to start adding some elements. So here's another chlorine to transfer another electron, because aluminum needs to lose 3 electrons to be stable. So we're going to add 1 more chlorine to make aluminum stable, and there we go. So now your compound is aluminum chloride. So this is practice, more practice, and again, you're going to be using this, the drawing or the shapes tool and everything on Google Slides to do this. Okay, so you have potassium and chlorine, magnesium and fluorine, aluminum and nitrogen, magnesium and phosphorus. So for potassium and chlorine, let's go ahead and walk through this. So potassium and chlorine, potassium looks like that. Chlorine looks like that. So that's pretty easy. So you have potassium chloride. We don't need to add any elements to that one. Next, you have magnesium and fluorine. We did need to add another fluorine here because magnesium needs to get rid of 2 valence electrons. So we have magnesium fluoride. Aluminum and nitrogen. They look like this. Aluminum can give away all 3 of its valence electrons to nitrogen, which makes aluminum nitride. And then magnesium and phosphorus looks like this. Magnesium again needs to get rid of 2 valence electrons. Phosphorus has some space, but it's still not going to be happy. So we're actually going to add another magnesium to make it happy, and then add another phosphorus to make this magnesium happy. But again, that second phosphorus is not happy, so we add 1 more magnesium, and we transfer those electrons. So we end up with magnesium phosphide like this. Okay. All right. If you guys have any questions, definitely let me know. I am here to help.